So Philippe is going to, as I just mentioned, the discussion is going to shift to materials, and this one is about material developments for stable, scalable, and efficient organic solar cells.
Okay, so thank you for the small time delay for that, but very happy to have the chance to present once again the company and what we are doing. So thank you, Kasha, for the presentation. So for those who doesn't know Brilliant Matters, we're a company specialized into material chemistry for printed electronic, and we really focus on our expertise in manufacturing such materials and on the reliability and purity aspect of the end product, and obviously using the cleanest process we can. So a brief history of what is Brilliant Matters and where we came from. So the company was founded as a spin-off of Laval University Technology in 2016. We started our catalog in 2017. We received our first funding in 2018. And we started developing our OPV first product in 2019, received first seed funding a year after. And right now we have our first industrial product, which is the Generation 1 OPV active layer. And we get funded to scale up the solution. So for those of you who doesn't know how a material manufacturer operate in the organic semiconductors world, we're mostly similar to we use mostly similar equipment than pharmaceutical industry, because it's fine chemicals, organic chemistry that enable the production of our product. So we're fully equipped with the 14,000 square feet lab, and we have a kilogram scale pilot reactor for those sensitive reaction. And at the end of 2024, we aim to have 100 kilograms a year of organic semiconductor in capacity. We also develop over time QC and also prototyping lab. So with those new capabilities, we are bridging the gap between the manufacturer who print those kind of devices and electronic, and the material side of that field. So why organic semiconductors are interesting for printed electronic? Basically, this is a molecule that we can modify the structure, and by modifying the structure, we are able to modify their optoelectronic properties and physical properties. This is an example. The point is not to give a chemistry course to anyone, but you can see on the top, if we modify the structure, the band gap, which is related to the absorption of light of the molecule, will be modified. So by fine-tuning those parameters, we can fine-tune the property of the semiconductor to the application we are aiming. And also by modifying those molecular structure, we are able to modify some physical property, such as the mechanical properties of the material, and the solubility of the material in different solvent, which give the material to have the to give the opportunity to make some ink from them in organic solvent, and after print them in processes that use standard printing processes to, at large scale, make electronic devices.